This is the video solution to practice problem A that accompanies sample problem 2.11 on page 64 of your text. This question asks us to write the chemical formulas for 3 ionic compounds. Remember that all formulas of ionic compounds are based on the charges of the cations and anions. The goal is to form a compound that has no overall charge using the smallest ratio of cation and anion possible. We'll need to determine the charge of the cation and anion based on the names of the compounds, and then we will need to combine these ions in such a way that the total positive and negative charges add to 0. In other words, we'll need to form an electrically neutral compound. Letter A is lead 2 chloride. The first thing that appears in this name is the identity of the cation. This is always true of ionic compounds. Lead 2 indicates that our cation is Pb with a charge of +2. The Roman numeral only tells us the charge of the cation. Our anion name is chloride. This has an IDE suffix which indicates that it is not a polyatomic ion. We'll have to refer to the periodic table to determine the charge on chloride. The chloride anion comes from chlorine, found here on the periodic table. We know that elements in this group, 7A, commonly form ions with charge of -1. In this case, the symbol for the anion will be Cl with a charge of -1. Now, our task is to combine these ions to form something that has no overall charge. One way to accomplish this is shown on page 61 of the text. We take the numerical value of the charge of each ion and make it the subscript for the opposite ion. I'm going to call this crossing over as I refer to it throughout this video. In this case, the subscript on the lead will be 1 and the subscript on the chloride will be 2. This is taking the numerical value of charge and making it the subscript for the opposite ion. Another way to think about this is to realize that since the lead has a charge of +2, it will take 2 chlorides, each with a charge of -1, to balance out the positive charge from the lead. Either way you look at it, the chemical formula of lead 2 chloride will be PbCl2. Next, we'll look at magnesium carbonate. Magnesium is the cation. We don't see a Roman numeral here, so magnesium must be a cation with fixed charge. It's found in group 2A of the periodic table, and we know that metals in this group will form cations with charge of +2. We'll write Mg2+ as the cation, and carbonate is a polyatomic anion. It can be found in table 2.9 on page 60. The formula and charge of carbonate is CO3 2-. In this compound, 1 magnesium with a charge of 2+ will cancel the negative charge from 1 carbonate. It isn't appropriate to cross over the charges here because they are the same magnitude, and we want the smallest ratio of ions in our compound. One other time that crossing over won't work is when the charges are whole number multiples of one another. The chemical formula for magnesium carbonate then will be MgCO3, which has 1 magnesium ion and 1 carbonate ion. Notice that we do not include the charges of the ions when we write the formula for the compound. In fact, it is incorrect to put the charges in the formula of a compound. Finally, letter C is ammonium phosphate. Ammonium is a polyatomic ion from table 2.9. Its formula is NH4 with a charge of +1. Phosphate is also polyatomic. I can tell this because it has an ATE suffix. It should appear in table 2.9 as well. Phosphate has a formula PO4 with a charge of 3-. Let's try crossing over this one and see what happens. The charge on phosphate is 3-, so we'll need to incorporate that 3 as part of the ammonium. What we need to show is 3 ammonium cations. This would be a total of 3 nitrogen atoms and 12 hydrogen atoms. The charge on the ammonium ion is +1, so we'll need to show 1 phosphate ion. There are a lot of ways to show these ions incorrectly, but only one correct way to show them. We'll place the NH4 in parentheses and a subscript of 3 outside the parentheses. This will give us the correct total number of atoms, and it also makes it clear to us that the cation is ammonium, NH4. By simply writing PO4, we will show 1 phosphate ion. No parentheses are needed around this one because we only need 1 phosphate. The chemical formula for ammonium phosphate is NH4 taken 3 times, PO4. Whenever you place parentheses around a polyatomic ion, make sure that you place a subscript outside of those parentheses. If no subscript is required, no parentheses are required. Being able to write the formula for an ionic compound is a really important skill. You'll have to know the polyatomic ions found in table 2.9 to be really successful at this. Please take a couple of minutes and work through practice problem B in this group. Check your solution with the key that's given on page 75 of your text and ask questions if you have them. It's important to get all of your questions answered at this time before they become problematic.